distinguished colleagues and representatives of VNIRO, of Russian fish industry, and as others say, persons interested in the development of Russian fisheries and beyond, producers and consumers of fish, and all of us are. I warmly welcome you at the joint FAO VNIRO session dedicated to the new review of Russian inland fisheries. It's a unique work. Nothing has been published over the past 20 years. We are going to briefly present its summary. And the full publication will be issued within 3 or 4 weeks. So I am coming to an end of my opening remarks and give the floor to Assistant Director General of the FAO, Regional Representative in Europe and Central Asia, Vladimir Rachmanin, who has come to Russia personally, which is a rare case given the COVID realities. This is the first visit of our regional representative in Russia over the past several years. Thank you, dear Mr. Kovikov. I believe you can hear me well. It's a great honor and pleasure for me to be here in St. Petersburg and to address you. I would like to apologize for having to leave you after my short remarks, but I couldn't have missed this opportunity. I thank you for your contribution to this remarkable publication. First, I would like to say that the Expo and the Forum have greatly impressed me, both in terms of content and scale. It's a great beginning, and this is the essence of Russian industry. So, my congratulations. We should increasingly demonstrate our successes and achievements of our Russian fishery industry. I represent the FAO for 8th year, and it's an effort for me to mobilize resources, knowledge of the former Soviet Union for FAO work. Of course, it's not due some resistance, but all countries joined the FAO in 1940s, 1950s. Our former USSR republics joined the FAO in 1991, 1992, 1993, and Russia joined the organization in 2006. So we haven't gained full momentum yet. I often tell a joke that Western Samoa for Russia is less exotic than Armenia. So coming back to Russia and to our publication, to interaction with Russia, this is crucial. It is crucial for Russia so that it could see what is being done globally, but it's important for the FAO as well to mobilize remarkable practices from our countries. So I would like to thank the Institute of Fisheries and Oceanography for their strides that they have made. I thank personally Mr. Kalanchin for his leadership. I am glad that this will be published both in Russian and English. This is vital for our domestic audience and for international audience as well. Our traditions matter. Today, Minister Patrushev, during the plenary, was talking about Russian scientific achievements in fisheries. And this is also something that we should contribute to the international life. Of course, these achievements are of Russian origins, but they should be known by the whole world. And so I am also glad that VNIRO is expanding its geographical cover in Russian Federation. Today, the Arkhangelsk region governor during the plenary was talking that the northern branch of VNIRO will be opened in Arkhangelsk and is being introduced into Arkhangelsk region tertiary education system. So I thank my Moscow office colleagues who have been working since 2014. Mr. Kobikov has been working here for 1.5 years, but it seems that this period has been longer. I thank my colleagues for their dynamic efforts and their contribution in our cooperation. Believe me, their enthusiasm it determines a lot in our work, and so I'm so grateful. I hope that this publication, apart from our presentation here, will also be introduced in Rome. We will find a platform to present this work. We in FAO also have several technical commissions on fisheries, and one of them is dedicated to inland fisheries, and this can make an important contribution. In 2022, a similar event will take place in Ireland, so I believe that we can present this review there as well. So here, on this note, I would like to thank you again for your attention. Excuse me for having to leave you, and I hope that we will have other meetings, but because we have 1.5 working days ahead. Thank you so much. Thank you, Mr. Rahmanian. I thank our ADG for his warm words, for his kindly remarks. FAO has a broad mandate that includes agriculture, although it is divided into several branches, for example, livestock, plant production, poultry production, forestry, primary forest products, fisheries, and like in all families where there are many kids, everyone is loved equally. And Mr. Rahmanian has made a lot to develop Russian fisheries, Russian science, and Russian science and fisheries has been present in important events long before Russia joined the FAO, even during Cold War, as we have found in archives. When we were preparing for 75th anniversary of the FAO, we found archive materials on 1967 visit under the auspices of FAO that was dedicated to fish behavior, depending on fishing gear that is being used. But of course, today our cooperation has expanded. It is being vigorously developed. And for example, yesterday, Rahmanin met with Mr. Shestakov, and promising agreements have been reached. This is not the first joint event and not the last one between FAO and Rosrybolovstvo. I would like to recall that as far back as in 2014, here in St. Petersburg, there was a session of FAO Aquaculture Subcommittee that also, alongside with other events, provided an additional momentum to the development of fisheries. And today, Rosrybolovstvo is discussing possible events for Fish Trade Committee of FAO in 2023. And since this joint session, I'm going to give the floor to VNIRO Director Kirill Kalanchin. Thank you, colleagues. It's a great pleasure. And it's so exciting to hold a high-level joint event. During a plenary session, other speakers said that Russia is not only an integral part of global fishery market, but also is a state that is seriously developing high-tech and using new methods. Today, both the domestic and the international markets are changing the direction of their development, and we are witnessing the transformations that we will face over the next several years. The proposal of FAO to take part in preparing such a publication that would touch upon Russian inland waters was both expected and unexpected. I can reveal a secret. We don't publish such materials annually. Even for our own necessities, we don't do that. So it was a scientifically rich material with statistics and trends and history, for example, of fishing gear, illustrations. So it's both scientific and statistical information that is of interest for fisheries experts, and just an exciting book that you can look through and familiarize yourself with what is happening in Russian Federation. We can only be glad and confirm during our communication with the colleagues that, of course, we still have a vital necessity for full-fledged cooperation with the organization. And the materials that we have today on fishery statistics help us to conduct analytical work, to assist the development of Russian fisheries, and thus influence global fishery markets. Of course, we have looked through historical background. The cooperation between our organization and the FAO has deep roots. And right now I would like to say a few words because I believe that we could deepen our cooperation, not just exchange statistics. I think we could resume the work of Experts Institute, and the fact that we have two leading experts here, Russian speakers, and that have Russian origins. This shows that the FAO clearly understand where to move further. So I believe that we need to analyze how to enhance this. We can propose to conduct several scientific workshops, for example, on human resources in fishery, on aquaculture. For example, we are strong in mathematical methods in fisheries, and also in compiling statistics on sustainable development goals. I think it could also be of interest to also resume workshops on board of our ships in the 1960s. For example, on board Academic Knipovich, the one of VNIRO vessels that was stationed in Sevastopol. Similar events were held there, for example, specialized workshops within 200-mile zones. Given that we are planning to build several cutting-edge ships, that the construction has begun in St. Petersburg, we are going to create a base that could be a source of knowledge for those who are interested. So we could suggest conducting such workshops on board scientific vessels and to look for possible fellowships. And several countries that are present at the forum have expressed their interest, so we are working on possible ways of cooperation. So it seems like a pretty good idea. Perhaps we could recreate scientific laboratories in regions to conduct research. Of course, they're also interested in receiving such materials, and this could serve as a way to jointly prepare human resources in the area. So again, greetings, dear colleagues and participants. Of course, we are waiting for the full version of the publication, and we are glad to see that fresh information, fresh statistics, and historical information is presented here. For example, we have data for 1963. This is several years before VNIRO creation. We are going to celebrate our jubilee, 140 years. The first biostation was created in 1881 in Solovetsky Islands, which marked the creation of our institute. Thank you, Mr. Kalanchin. On behalf of the FAO, I congratulate VNIRO. Happy birthday. We will try to present you a substantive present, but I believe that the best gift is the opportunity to participate in a large international exchange. I hope that COVID restriction will soon be lifted. Although I believe that fisheries is stronger than other agricultural branches, but the process of recovery is underway, and no doubt Russia and its leadership in this region, in fisheries, perhaps excluding aquaculture, is undisputable, and Russia has nothing to learn here. So VNIRO should play its part as a platform for expert meetings, for exchange of experience among international experts, and thus contribute to fishery sciences development. It's important because we have SDG 14, conservation of water ecosystems. It contains a number of targets in fisheries. Although SDG 14 is not the single point in the 2030 development agenda. For example, we have SDG 6, sustainable water management and sanitation, and the state of water resources after aquaculture use is of great concern. Acidification of oceans, waste pollution, abandoned fishing gear, as well as the problem of general climatic changes, including temperature rise, the rise of ocean level, and for example, for small developing island states, this is a matter of life and death, because if we are unable to achieve the indicators set out in climatic agreements, for example, the Paris Agreement on Climate, many of these countries will simply be swept away or will be forced to literally live on board their vessels. Of course, it's a joke, although FAO takes this seriously. We have long looked with admiration at the VNIRO scientific vessels, for example, that visit various shores, and we welcome the proposals to organize laboratories in developing countries, for example, in Africa. Perhaps these countries will feed humanity within several years or decades, and this organization can be a tool for saving people from poverty. I would like to reiterate that the country that has 2 decades ago was firmly on bottom of list developed countries, and that was regularly shaken by natural disasters and suffered from food deficit. But thanks to the development of fishery and agriculture, has managed not only to lift itself from poverty, but now is firmly in the list of middle-income countries. Russia is in the same category. So let's go back to inland fisheries, and now I give the floor to Rome, to our friend, our leading FAO expert on inland fisheries, to John Jorgensen.
Thank you very much. Do you hear me clearly?
Hear you loud and clear. Перевод идет? And translation, yeah, comes through too. Please go on.
Good afternoon, Dr. Rachmanian, Assistant Director General of FAO, Dr. Kolon-Chin, Director of VNIRO, ladies and gentlemen. It is a big honor and also a great pleasure for me to address you all today. Russia is a major producer of inland fish with a long tradition in this subsector. And not only that, it also has an excellent potential to further expand and develop inland fisheries in the future. And what I'm going to talk to you about today is precisely inland fisheries, the global status and trends. First, I will be talking a little bit about inland water ecosystems, and I will move on to inland fisheries, give some characteristics, some statistics, and talk a bit about their contribution to food, nutrition, security, employment, and economy. Then I will move on to the assessment and or how we should or could assess the status of inland fisheries.
Excuse me, John, you have a presentation, if I'm not mistaken. So could you please share your screen?
Yeah, sorry about that. Yeah. You see it now?
Beautiful, we see it, we see it.
Yes. Then I will finally talk a bit about the what's needed to achieve sustainable inland fisheries. Inland waters cover about 2.7% of Earth's land, or 3.7 million square kilometers. For comparison, the area of the Russian Federation is about 17 million square kilometers. This means that for every person on Earth, there is about 470 square meters of surface for a freshwater area. Still, these inland waters are important ecosystems that provide essential services to people, including clean water, flood protection, recreation, carbon sequestration, food, and employment through inland fisheries. Inland ecosystems provide habitat for a long series of organisms, and these freshwaters are highly diverse. We have inland seas, we have rivers, streams, ponds, reservoirs, floodplains, lagoons, and wetlands, and many more. And inland waters provide habitat for more than 40% of the world's fish species. If we include also the species that live both in the sea and in inland waters, it's more than 50%. People make use of these species through inland fisheries, and these inland fisheries range from small-scale commercial operations to very large-scale ones of similar size almost as the ones used in the sea. some people also use inland fisheries mainly for subsistence, to feed their own families and themselves and their communities. These people are mainly indigenous people. And finally, some people just use inland fish for recreation through recreational fisheries. To some extent, sometimes it can be difficult to separate between recreational fisheries and subsistence fisheries in the cases where the fish is being retained and taken home to use for food at home. However, in general, inland fisheries are small-scale activities that are integrated in rural farming and herding. FAO has been compiling statistics on inland fisheries since 1950. And as you can see in this graphic, the catches have almost continuously increased ever since then. Until now, we have just about 12 million tons of inland fish being caught every year. We are not really sure whether this is due to really increasing catches, or this is simply a result of statistics having improved over time. FAO is not collecting the statistics ourselves. We are compiling the statistics that are being offered to us or sent to us by our member countries. There are a number of problems with inland fishery statistics, but I don't have the time to go into depth with those now. What we can say is that inland fisheries does contribute significantly to the global production of food. We look at finfish production. The world produces around 150 million tons of fish per year. Of this, about 84 million tons comes from the sea, 54 million tons from aquaculture, and 12 million tons from inland fisheries. However, out of the marine catch, roughly 22 million tons are being processed into feed that are mainly fed to fish in aquaculture. So if we take this into consideration, about 10% of food fish comes from inland fisheries. And that is just using the official data. This is equivalent to the full dietary animal protein requirement for 160 million people, or 2% of the global population. We have done some research and modeling, and according to this, we do believe that real catches could be 65% higher, or about 20 million tons. If we are talking about recreational fisheries, then it's about 67% of the world's population that participate in this. It is typically more important in developed countries. However, many developing countries are also increasingly dependent on recreational fisheries. And there are actually, we don't have very good statistics on this at the global level, but there are indications that the retained catch from inland recreational fisheries could be quite substantial, and perhaps between 5 and 10% of the total global reported catch. And this is due to and here this problem of separating recreational fisheries and subsistence fisheries come into play. And this partly explains why there is an apparent underreporting of inland fish catch in certain countries in Eastern Europe, Russia, Ukraine, Central Asia, and in North America, all countries where recreational fisheries are very important. So where in the world do we have inland fisheries? If we look at this map, we can see that about 2/3 of inland fish is being caught in Asia, where China produces about 20% of the total catch, South Asia about 21%, and Southeast Asia 23%. Another big part of the inland fish catch comes out of Africa, especially the Great Lakes region, West Africa, and the Nile Basin and the Sahel area. Outside these areas, you see another big contribution comes from the Russian Federation, which produces about 2.5%, which is almost as much as the entire region of South America. So inland fisheries contributes significantly to the dietary intake, food and nutrition security among rural populations in at least 100 countries. And even in situations where the overall contribution to the national catch is low, there may be area at the subnational level where there are few alternative sources of animal protein available, and in these cases, the per capita dependency may still be very high. This is especially true in landlocked and low-income food deficit countries that are disproportionately reliant on inland fish. We can thus see that 43% of the world's inland fish is harvested in 50 low-income food deficit countries. And 15 of the 21 top producers of inland fish are actually low-income food deficit countries. Inland fisheries constitute an accessible source of affordable protein and micronutrients, which is why they are so important in these countries. And the reason is that inland fisheries are mostly open access, and they require low level of investment to participate, and therefore they can provide a safety net under people that are losing their jobs or for other reasons come into difficult situations in times of crisis. Inland fish decreases malnutrition, enhances health and well-being, and help mitigate impacts of disease among the poor. It also contributes to improve the health of women during pregnancy and contributes to healthy child development during pregnancy and during the first 1,000 days after birth. And the income from fish is also important in increasing purchasing power for rural people for other food items. And importantly, inland fisheries are very efficient producers of food. And if we compare to aquaculture and livestock and production of other protein-dense food, inland fisheries use far less land, water, and feed. And they produce food with a much smaller carbon footprint than, for instance, marine fisheries. Inland fisheries employs a lot of people, although this is usually a part-time occupation. Between 16 and 20 million people are directly employed in inland fisheries, and another 8 to 38 million people are working in post-harvest. This is more people than are employed in marine fisheries. and corresponds to between 2.5% and 6% of the global agricultural workforce. And more than 50% of the people working in the inland fisheries sector are women. The economic value of inland fisheries is rather high, with $26 billion per year from the food fisheries. And if you take the hidden catches into consideration, the parts that are not included in the official statistics, this would increase to 43.5 billion. The value of recreational fisheries, however, is even higher, with $44 billion per year in direct costs and more than 100 billion per year in indirect costs. So what is the status of the world's inland fisheries? This is not an easy question to answer. FAO monitors and reports to the FAO Committee on Fisheries, COFI, on the aggregate status and trends for 455 marine fish stocks, corresponding to about 80% of the total global catch. This assessment is based on stocks that are routinely monitored, and it is indicated if the stocks are underfished, sustainably exploited, or overfished. However, we do not have a comparable system to assess the state of inland fisheries. Among other things, this is because there are far more individual fish stocks in inland waters than in marine. If we were to monitor 80% of inland fish catch, we would need to monitor more than 50 river basins. And most of these fisheries are not regularly monitored, and most of the stocks have not been defined. Further, the marine assessment is only looking at the pressure or the impact from fisheries. For inland fisheries are far more complicated. Inland fisheries are situated in landscapes where a lot of other human activities are taking place, including mining, deforestation, damming, irrigation, aquaculture, etc., etc. And these human activities have and will continue to impact freshwater ecosystems with pollution and fragmentation of the ecosystems, diversion of river canals, water abstraction, introduction of alien fish species, etc., etc. It's essential, you must understand that hydrological connectivity is an important part of river basins. Whatever happens in one part of the basin will quickly affect all areas downstream. In addition, we have fish that are moving in different directions, both upstream, downstream, and also laterally into wetlands. And if the basin is being fragmented due to damming, for instance, then it is going to damage the fish stocks. So in order to assess the status of inland fisheries, we would need first an assessment framework that can provide an objective evaluation of the fishery resource. We need to identify current and future threats and drivers and vulnerabilities. We need to identify adaptive capacity and options to mitigate these threats, both within the fishery and outside. And we need to develop an approach that can be replicated in order to measure or track changes. Together with the partners, we have made a first attempt that was published in the last issue of the State of World Fisheries and Aquaculture. Here we have looked at 34 basins and tried to look at develop an index based on 20 different pressures. So the dark pressures are the areas that are under most pressure. And we can see here that some of the dark areas are some of the areas that also are among the areas producing most of the fish, for instance, South Asia and parts of Africa. The situation is much better in some parts of Russia, for instance, which apparently is under less pressure and with a better prospect for the future. An important point here is that we have another challenge here, and that is that the countries it is countries that are reporting to FAO, and they are not reporting catches or the situation of the stocks by basin. And what makes most sense if you are going to assess the status of the fish stocks is to look at it per basin. And in many cases, there are several countries sharing the same basin, and it's very difficult to combine the data because they are not always directly comparable. However, at the national level, it is also clear from what I just said that sustainable management of inland fisheries will require a clear articulation between the different institutions that are responsible for fisheries and the institutions that are responsible for planning and development of land and water resources in the region or basin in concern. And inland fisheries water needs and aquatic habitat integrity must be clearly communicated to all the other sectors that use or impact water resources and aquatic ecosystems. And it needs to be highlighted to them also what the economic, environmental, and ecological information that shows why inland fisheries must be taken into consideration. In summary, inland fisheries are highly diverse and vulnerable ecosystems providing essential services, including inland fisheries. Inland fisheries provide employment, income, food and nutrition security for the rural poor. Inland water ecosystems are under pressure from a range of human activities. And sustainable inland fisheries management requires holistic and inclusive development approaches among sectors having an impact on aquatic ecosystems. Here I just show a number of the products that FAO has developed on inland fisheries and the address where our work can be downloaded. I would like here also to mention that we are in the process of undertaking a series of reviews of some of the countries with major inland fisheries. The first of these reviews, probably one of the first, is the one we are doing together with VNIRO on the inland fisheries of Russia. And I would like to express my thanks to Dr. Kulon Chin and VNIRO for the excellent collaboration in developing this publication, which will be out quite soon. Thank you very much. Spasiba.
Thank you so much, John. So I will pass without delay word to Vladimir Alexeyevich Belyaev, the coordinator of this work at VNIRO and the person who was really behind the team and our inspiration and who accomplished it in time to be presented for this session. Vladimir Alexeyevich, прошу вас.
Thank you so much. Good afternoon. Indeed, this work has been quite complicated because the last part that consisted in generalizing this work was the white paper of 2002. And this white paper published in 2002 was only about European part of Russia, although we know perfectly that all the territory of Russian Federation is covered in rivers. It has many lakes and other water bodies. And so this publication, when we prepared it, of course, we had a certain period for doing this, and the deadline was quite tough. And the work that will be published soon by FAO, I think, will set the ground for a more serious and more large-scale work. And the next publication will be prepared with the participation of all of VNIRO branches, so all scientists of Russia will take part in it. Of course, we had some problems in the process, but we overcame it. And at the moment, we are going to present the review. Anna Pavlova will present the publication. She is one of key specialists. Although many people participated in the preparation and including the preparation of summary, I would like to wish that our research institutes would not only have a strong marine research component, but also freshwater research units. Given the number of people participating in fisheries, including recreational catch, all of us live near rivers and lakes. Russia has always been a country of rivers and lakes since the most ancient times. Thank you. Thank you so much. It's a pity that you have to leave us, but we are going to continue our cooperation. And crucially, we will continue our joint work because we have seen that thanks to our joint efforts, Russian inland waters have been better studied than in many other countries. I greet all the participants in the forum. I would like to start from a bit far away. Fisheries has historically been established earlier than other trades. It was developing the fastest after the 1861 reform. This was contributed by the creation of market of fleet, the construction of railways, the abolition of salt excises played a major role because salt is the main preservative of fish. In pre-revolution Russia, official fisheries statistics that would reflect the state of fisheries did not exist. Although we have some data that could indicate the number of fish that was extracted in various periods, the species and the fishing gear, and this is due to the efforts of, for example, Danilevsky, Grimm, Vishnyakov, Kevdin, and other specialists. Not only the collection, but also the processing of information was complicated. In some cases, catch was taken into account by weight, in other by numbers. In some data, we only have the weight of raw fish. For other species, for some species, the measure units were different. For example, large ordinary fish, sturgeons, were assessed differently. Fishery statistics for inland waters in different periods varied greatly. When organizing species accounting, it had to be understood that many species were named differently in various regions. For example, different genuses could be named differently. In Kolyma, chibak stands, for example, for various species in other regions. Carp is called nelma in some regions. Also, accurate statistics were difficult. For example, if we're talking about consumer fisheries, in 1930s, fisheries were mostly conducted in inland waters, and most of them were in the Caspian Basin. After revolution, inland fisheries were destroyed to a large extent. In 1920, fisheries in Russia shrank to the level of 1915. By the end of civil war, and after the creation of General Agency for Fisheries and Fishery Industry, GlavRiba, the adoption of acts on fisheries and the state public investments allowed to Russia in 1925 to approach the level of catch that comprised 70% of 1913. During the Great Patriotic War, the specialists of fishery industry had a task to expand catch in all water bodies. In 1950, over 40% of all fisheries was accounted for inland fisheries. In the 1950s, the process of creating material and technical base for ocean studies was established. In 1990 and in our times, the volume of catch averaged on 243,000 tons. It has always been an important income for food and employment for the population, but over the past 100 years, its significance has decreased. The main reason is the multi-purpose human activities, for example, reclamation for agricultural purposes, water intake, industrial and household waste pollution, and reorientation of fisheries for ocean and marine catch. In the Soviet Union, inland fisheries meant not only catch in lakes and rivers, but also fisheries in the Black, Caspian, and Aral seas. In some cases, the White Sea and the coastal zone of Baltic Sea was also included in this industry. We also had to separate the former Soviet republics' data from Russian data. We also had to unify species names and to use officially adopted literary names. Today, Russia has over 22 million hectares of lakes, 143 million hectares of ponds. Russian fisheries scientists regularly generalizes data for 50 units of fisheries in freshwater bodies. Inland water fishery can be characterized by several types of industry. For example, capture fisheries, scientific and control purpose fisheries, recreational fisheries, sport fisheries, as well as fisheries aimed at ensuring traditional way of life for indigenous small peoples of the North and the Far East. In the Russian Federation, there is a clear correlation between water resources and the population living near them. Nearly 90% of water flow is accounted for Arctic Ocean. Over 80% are living in the latter region, and the main processing capacity is concentrated there. In 16 regions of Russia, capture fisheries is not conducted at all. The fisheries region of Russia are divided into 8 basins: Far Eastern, Northern, Western, Azov-Caspian, Volga-Caspian, Azov-Black Sea, and Baikal. Volga, Caspian, Far Eastern, and the Western Siberia basins take the largest share. Carassius, bream, pike are dominant in the catch. Rivers account for the major part of fisheries, and the lakes and reservoirs account for 12%. The role of inland waters in Russia is important both in terms of employment and in terms of food security. And these two sides of inland fisheries are strongly correlated. The employment in inland fisheries has decreased. Before 1990s, major part of coastal localities was focused on fisheries. For example, men captured fish and women processed it. The conditions for employment have deteriorated. There is no environment for the development of the industry, and the traditional fishing gear for inland fisheries are such items as, for example, dredges, seine nets, and low tonnage and small vessels are mainly used in this type of industry. We also record the high level of deterioration of the fleet, including fishing gear and processing plants. Capture fisheries in most water bodies is mainly focused on capturing high-value species, white fishes, pike, perch, and in some cases the volume of catch exceeds the total allowable volumes. And the stocks, for example, of perch is underused, which leads to substitution of high-value species with low-value fish. In modern Russia, the function of control, oversight, and protection of aquatic resources is in charge of a number of entities that control industry and protect water bodies. Apart from ensuring biological diversity of water bodies, officers of territorial entities combat poaching and legislation violations. Waste discharge, the use of protected water zone with violations of relevant legislations are among the most common breaches of law. Also, these areas need to be protected from the damage caused by construction and introduction of new technologies. Aquaculture farms release over 9 billion of high-value fish due to state order and using their proper funds. The annual volume of release of aquatic resources exceeds 30,000 tons of fish. Problems of freshwater inland complex include the following: orientation of fisheries towards the use of commercially most valuable fish species, sturgeon, salmons, whitefishes, pike perch, and the stocks of less valuable species in underused almost everywhere. The multi-species nature of fishing creates difficulties to its regulation through the establishment of tags, insufficient consideration of the needs of fishery complexes in the region when establishing water flow regimes through hydraulic structures of energy facilities, low investment attractiveness of fisheries in the regions, and the lack of government support measures for the enterprises of the fishery complex, similar to supporting measures for agriculture. To effectively manage fish complexes, it is suggested to develop a number of measures. For example, develop measures to preserve and maintain of grounds for spawning, feeding, migration, and wintering, expanding work on the artificial reproduction of flowers to enhance fisheries in inland water bodies, development of mechanisms to ensure adequate monitoring and surveillance of fisheries in inland freshwater bodies, development of mechanisms regulating the way of fishing during periods of fish kills. Another important issue is the state support for the construction and modernization of small tonnage vessels for the fishing fleet of inland water bodies. Given the importance and relevance of the main areas of development, the Federal Agency for Fisheries, together with executive bodies of Russian Federation, is planning to create an efficient strategy for inland fisheries development of the Russian Federation. Thank you for your attention. Thank you, Anna, for your detailed narrative on the state of Russian inland fisheries, for the historical overview and the overview of current status. Distinguished colleagues and participants, we are going to give the floor to representatives of VNIRO regional branches, and it is our pleasure to hear of the state of fisheries in your regions, on your work in this field, and we will be glad to receive your comments and your suggestions to the FAO on areas, ways, and means of our potential cooperation. So we will start with the head of St. Petersburg branch of VNIRO. You can speak from your seat if you wish. The first slide, please. I would like to outline the state and dynamics of aquatic bioresources in north and west of Russia. Our area of responsibility includes both the western fishery basin and a small part of northern basin, so I will touch upon both of them. This region is characterized by a large number of lakes, over 80,000 lakes, and 1,000 kilometers of rivers. I would like to emphasize that in our region, the largest lakes are concentrated, the largest in Europe and in the Russian Federation, excluding the Baikal Lake. As you can see, we have Onezhskaya, Ladorskaya, Ilmen, Chutsko-Pskovskaya lakes, and a number of small reservoirs. I would like to mainly focus on large basins that are more important for industry. Over 50% of catch is accounted for by three lakes, Chutsko-Pskovskaya, Ladorskaya, and Ilmen. You see general total catches divided by main species, I would like to stress that the maximum catch is comprised by carps, including, in particular, bream. We don't have a lot of fishing gear used here, despite the fact that water bodies are very different. For example, these are seine nets, set fishing gear, traps, fences, and the nets, mainly stationary nets, and in some cases floating nets. And now a few words on the largest northwestern lakes, Ладожская, Онежская, Чудская, Псковская, and Ilmen lakes. Ладожская lake is the largest water body, over 18,000 square kilometers. Onежская is over 9,000. Чудско-Псковская over 3,000 square kilometers. The base of fisheries is a smaller Chudsko-Pskovskaya lake. Ladozhskaya lake is one of the largest lakes, but it has one of the greatest. It's a case of great biodiversity. Almost 50 species can be found there. A bit less can be found in the next two lakes. The least number of species is found in Ilmen. This is due to the difference in the number of biotopes, because Ladozhskaya lake is not only the largest in terms of surface, it's the deepest one, and so biodiversity is higher there. We have the most valuable species, for example, lake salmon, a number of white fishes, vendas, and the standard carps and the perches. Onezhskaya lake is similar to that because it's situated in the north as well, and it also contains valuable fishes. With regards to Chudsko-Pskovskaya and Ilmen lakes, they are more shallow but more productive as well. As you can see, if we look at the dynamic of catch over the 75-year periods, of course, Chudsko-Pskovskaya lake accounts for 84,000 tons. If you look at the catch dynamics in the largest lakes over the past 5 years, our publication goes as far back as 5 years. You can see a very diverse trends that are determined by the state of stocks. As for Ladovskaya lake, we see a decreasing trend. As for Ladozhskaya and Chudsko-Pskovskaya lakes, the trend is for growth, mainly due to carps, in particular bream. As for Onezhskaya and Ilmen lakes, despite some annual fluctuations, the state of stocks and catch are more stable, without any clear trends. If we look at a longer period, we will see both decreasing and increasing trends, which are caused by various factors, for example, climate, weather, industry practices, because in the period of 1930s, there was no harvest at all, virtually. Then it resumed almost in all water bodies. And after 10 years of large volumes of harvest, they started to diminish. At the period, a number of measures were taken for some water bodies that limited fisheries, that also limited the use of some fishing gear, and then fish stocks started to replenish. I was talking about mainly human-induced impacts, but if we're speaking about the climate, in the 1970s, in Pskovska Lake, there were large stocks of vendas, but then the environment changed, and mainly bream and pike perch were found there. So it's the only water body where the structure of fish species changed so greatly. But in terms of commercial harvest, of course, this changes for the good. I wouldn't like to take a lot of time, but I would like to emphasize the general dynamics of catch by the most valuable fishes. If we look at white fishes, it's mainly harvested in Ladorskaya Lake. Starting from 700 tons, we only have 100 tons today, unfortunately. And in other water bodies, the stocks were even lower. Speaking of vendas, there were periods of large harvests in Chutskopskovskaya Lake. They were also significant in Ladoga and Onezhskaya Lake, but unfortunately, harvest started to decrease. The catch of carps are growing, for example, in Ladorskaya Lake, and we clearly see the trend, the increasing trend. We believe that such changes happening in the structure of fish species cannot be considered negative, although, of course, the structure radically changed due to climate factors. We are all talking about climate change, the growth of warm period, the contraction of glaciers, and of course this negatively impacts all spawning fishes such as vendas and whitefish. A couple of words on threats to fish stocks in inland waters that are mainly common in our region. Talking about the northern fishery basin, the main threats are the impact of industry, the aquaculture, as well as human-induced influence caused by utilities activity. And if we look at western fishery basins, the picture is a bit different. Of course, there is pollution mainly by biogenic elements, since a large proportion of population is concentrated there. And of course, the pressure of fishery is significant there. I would like to particularly stress climate change that has the most significant impact on biosphere in the region. Thank you so much. Could I please take a couple of minutes of your time? I would like to invite all our colleagues to ask questions. Of course, we now have a joint conference, and our colleagues from Rome also join us. If we talk about the structure of catch, giving allowances to other factors, what are the share of capture fisheries, including small-scale and artisanal fisheries, as well as recreational and sport fisheries? Of course, the situation is different for various water bodies. Since today we were mainly focused on large water bodies, of course, capture fisheries are more important there. Speaking of Ladoga, today, of course, near-shore fisheries are more important, although is mainly a marine term. In the shallow waters, we remember that smelt is an emblem of St. Petersburg, and the appropriate fishing gear are used to catch it. Many fishing gear are prohibited at the moment. Perhaps the prohibition will be lifted later if stocks are replenished. A similar situation is recorded in Chutsko-Pskovskaya and Ilmen lakes, where industrial fishing is mostly prevalent. In Onezhskaya lake, industry is less developed, and at the moment we can state the underuse of stocks. Well, as for recreational fishing, of course, accessibility is a key factor here. If we have large cities nearby, and this is relevant for Ladoga, for example, in the southern part, a lot of amateur fishers go there. As for Ilmen and Chutsko-Pskovskaya lakes, some cities are in close proximity, but given the fact that these lakes are productive and capture fisheries are active there, recreational fisheries are less developed. As for these lakes, of course, we are planning to assess recreational fishing for these water bodies, at least in the near future. What is the potential? They're right to call it recreational fishing, of course, including fishery tourism for highly valued fish. What is the volume, the cost of this type of fishing? If you're talking about everything that is related to that, I mean, well, of course, I'm not only talking about catch. In many regions, fish can be expensive and it could serve as a source of income. Yes, the value can be quite high, and in all water bodies, despite all the differences in their size and productivity, there is an opportunity to develop this kind of tourism. The last question: which countries whose experience with the similar conditions can be used here? Perhaps US, Canada, Finland. Yes, Finland is a northern country as well, but in terms of industry organization, I would like to know that we had a trilateral project, because the Chutsko-Pskovskaya lake is a transboundary water body. So we have a project on assessing the state of ecosystems, of fishery impacts. And this project was jointly conducted with the Netherlands. They mainly, of course, we studied a water body where the pressure of amateur fisheries is quite high. Although in Netherlands the density of population is incomparable with our region, they have other priorities. recreational fishing is mostly developed there, and in our case, the significance of industrial fishing is greater. Thank you. I would like to continue our discussion, but we have to give the floor to your colleagues. And now the floor goes to Mr. Plukhin, head of Volga-Caspian branch. I believe that fish is the most tasty there. Thank you. In modern times, industrial species include over 40 species of Volga and Northern Caspian Sea, although catch of some of them has been limited. In essence, industrial fishing covers only 25 species. Over the past decades, the situation with aquatic resources extraction has been changing, which also was reflected in the prices of bioresources, which also depended on area of origin. The main factors that determine the state of stocks is the regime that is active in Volga. The disruption of the state of this water body determines the stocks of several species, such as bream, for example. In order for fish to spawn and to reproduce, temperature should be low enough. For example, the 2019 generation of fish of bream and roach will be partly destroyed and unavailable for catch. Total stock of fish species varied greatly over the past 2 decades, from 33,000 tons in 2004 to 215 in 2017. The stocks of fish allowed for catch decreased from 2017 to 200 tons. And other species also decreased, especially if we're speaking about roach, whose catch decreased from 7,000 tons to 1,700 tons. This is mainly due to a large number of amateur fishers who consume only 2,000 tons of roach. The stable trend in this category is mainly ensured by stocks of other species. Mainly these are freshwater species. Speaking of Caspian Sea, it is the largest inland water body. Formerly, the stock of sturgeons there was the largest one. Today, the Russian Federation doesn't conduct a commercial catch of sturgeons. They are only being caught for scientific purposes and for reproduction. In the Caspian Basin, our Russian is the main contributor to sturgeon reproduction. Thanks to Russian efforts, approximately 70 to 80% of all young fishes are being released. But unfortunately, the IUU pressure disrupts these positive efforts, because poachers harvest this fish before it reaches any significant size. Here in the bottom, you can see that The reproduction of fish, natural reproduction of sturgeons is also present, and sometimes it is being recorded during scientific purposes harvest. Russia has a great resource potential of marine fish species in the Caspian Sea, approximately 500,000 tons. Recommended catch size is about 120,000 tons. These are mainly the stocks of Caspian spread that have recovered starting from 2010. According to Volga-Caspian of VNIRO branch recommendations, in the western central part of Caspian Sea, in 2019, the first trawling harvest of spread was organized. In January and March 2021, the number of vessels reached 20. The recommended over 2020-2021 fishing season, the catch reached almost 27,000 tons, and this number is 4 times higher than for the previous season. The most significant IUU pressure is to high-value fish species. The most favorable conditions have been created for less exploited fishes. If industrial fisheries on Caspian Sea is recovered, then the volumes of catch will increase several times, mainly due to spread catch. Well, we are glad to hear such good news and to hear about positive prospects. Well, traditionally, I would like to know that you have made a leaflet for your region. This is a photograph of your local sea. Of course, Sprat comprises a large portion of marine industrial catch, and given the exponential growth of aquaculture, it largely goes not only for human consumption, but also for the production of feed for aquaculture. So the potential of Caspian spread is huge, and so important developments are underway here. Now we are working on not only on the harvest of anchovy spread, but also of Caspian spread. We are now developing various methods for harvest, not only for deep trawling in wintering regions, but also using light tools, because light attracts fish. If we use these methods, if our businesses show demand for this, then we will organize annual harvest, which will allow to increase the volume that will be presented in the market, and therefore prices will drop. Thank you, dear colleagues. Unfortunately, we are running out of time. We have already exceeded the time limits, so I would like to suggest that our next speakers present a shorter version of their speeches. Now we'll hear to Mr. Katsuk, head of Khabarovsk branch of VNIRO. Good afternoon, dear colleagues. Let me present to you a review on the state of Amur resources is the 10th largest river in the world, the 4th largest river in the northern hemisphere, and the largest river in the Far East. Pacific salmon can be found there. Several regions are covered with this river, and this river also crosses our boundaries and flows through the territory of Mongolia and North Korea. Amur is a unique ecosystem. Only freshwater species exceed 150, and now we are developing forecasts for 25 freshwater species. You can see the dynamic of harvests on the bar chart. Anadromous species are mainly included here, Pacific salmons and roaches. The increase of recommended catch in 2015 and 2008 was determined by the growth of anadromous species, which are mainly comprised by Pacific salmons. The first species, it was the volume of harvest was over 40,000 tons. The last period of low stocks lasted from 1970s to 2000, to the year 2000. Over the next 30 years, the catch will around 12 to 15,000 tons, although we are not insulated from the decrease in fish stocks, which has been witnessed for the past 3 years. Roaches are another anadromous fish. This species constantly lives in Amur, and the catch of both species varies from 3 to 5,000 tons. Sturgeons also have a certain potential for industrial catch, which is prohibited for the moment. In the northern area, sturgeons have been included in the Red Book of Species. In 1920s, the catch of sturgeons was around 1.2 thousand tons, and in the Soviet period it varied between 20 to 50,000. And after 2008, it dropped due to the prohibition of industrial catch. However, it was only prohibited in the former Soviet republics and in Russia, and in China there was no such prohibition. And in 2008, China accounted for 26,000 tons of black caviar production. We failed to reach an agreement on the prohibition of commercial catch in this region. And so China harvested almost 5,000 tons by 2015. Here we have the data of the last studies. We assessed biomass of each species. For example, if we speak about Amur sturgeon and other species. Also, we conduct artificial reproduction. We have 2 plants in the Amur Basin. Total release comprises up to 2.5 million tons. We have methods for example, genotyping. We are recording high efficiency of these methods of artificial reproduction. Sometimes the volumes reach up to 40% of all young species. And speaking about industrial species, Amur is the richest one in terms of biodiversity. As in Volga-Caspian Sea, the flooding season determines the volume harvest, but due to damming, the water flow changes, and so the level of water in floodplains isn't favorable for fish reproduction and catch. After 1970s, we have been witnessing the decrease in fish catches. There are two reasons for that: the Great Patriotic War, and after 1970s, 1980s, we don't have accurate statistics. We have other types of industrial fisheries. One of them is the so-called traditional fisheries of indigenous small peoples in the Amur basins. According to the last census, approximately 17 to 18,000 of indigenous people inhabit this region, and they have their own quotas that have not been reflected in these statistics. And of course, recreational and sports fisheries that are not being accounted for. Each kind of fisheries is comparable to industrial catch in terms of volume and comprises approximately 6,000 tons of industrial species. Of course, we also have introduced species that come from China. For example, pike perch is our native species. Now we are conducting industrial catch for this fish. And there are non-commercial species in the Russian Federation. Bivalves also have a certain export potential in the Amur Basin. Our colleagues in China highly value this type of mollusks. We regularly monitor the state of stocks in water bodies, for example, using UAVs and geoinformation systems. On this slide, you can see photographs taken by our experts when assessing the number of spawning Pacific salmon. Thank you for your attention. Question: what is the forecast for salmon season in this year? We have not provided any justification for catching Pacific salmon, only for purposes of science, because the outlook only allows for fish pairs, and in autumn, 13,000 out of 13,000, 5,000 tons have been caught for traditional fisheries, and around 1,000 tons for recreational fisheries. So the caviar will not be cheaper this year. Now, Mr. Kajurin, head of Azov Black Sea branch, in 16 o'clock we will have another event here. Distinguished moderator, distinguished colleagues, I would like to put it briefly. I have a different format. I will compare industrial fisheries with aquaculture in Azov Black Sea Basin. You will understand why. I would like to focus on issues that are impeding the development and the use of fishery resources. In my review, I will not provide information on the Don River, because Don cannot be considered a freshwater water body because it receives water from Azov Sea. It doesn't have a significant fish stock, and so catch volumes are mainly ensured due to semi-diadromous species. So I will talk about the main reservoirs, for example, Tsemlyanskaya Reservoir, Manach Cascade Reservoir, Krasnodar and Stavropol regions reservoirs. According to the last studies outcomes in 2017, the fisheries water bodies cover almost 400,000 hectares, which are mainly comprise reservoirs. For commercial catch, mainly small water bodies are used, 48,000 hectares, and dammed ponds are used for productive fisheries. The catch last year comprised almost 150,000 tons. 74,000 tons out of them are accounted for by aquaculture. Given the numbers, the most part of fish products are ensured by aquaculture. Under maximum control, the conditions for aquaculture are partly controlled. The maximum productivity is expected at 22 to 2,500 per hectares. In small ponds, productivity is a bit higher, and 0.02 tons per hectare has been recorded in dammed ponds. Aquaculture requires a number of arrangements, for example, melaration, water treatment, and feeding. And some farms reach 35 The efficiency of products used varies greatly. For example, in the Rostov region, in some estuaries, aquaculture has been conducted for 6 years, and so 6,000 tons is harvested annually. In other reservoirs, for example, one of them is 24,000 tons, and so productivity is very small, only 500 tons per year. And in Semlyanskaya Reservoir, which is 270,000 hectares, 27,000 tons is harvested each year. Carp and white carp are among the most valuable species here. And over the past years, almost 80,000 tons is this overall volume, but in terms of species structure, less valuable fishes substitute the others, and the number of such fishes as bream and carp are decreasing. There are some common problems in our regions. Other speakers have mentioned some of them, for example, industrial waste, as well as recreational harvest that is hard to account for. And we believe that main problems here are artificial reproduction. At the moment, in the Rostov region, in southern areas of Russia, only one reproduction plant in Tsemlyansk Reservoir produces 2.5 fishes, whereas we need around 60 million fishes for stock reproduction. The level and all these reproduction plants require modernization. Their state is catastrophic in some cases. Another issue that I would like to stress is melaration. In natural water bodies, it is not conducted or is limited. In small to medium-sized water bodies, large-scale works are required, but it's impossible due to objective reasons. So we have to only treat the spawning areas, spawning grounds. There are some other areas for development. For example, we need simply to clean water bodies. We need specific legislation to regulate this issue. So these are the points that I would like to stress. So if we have run out of time, I would like to end my presentation here. We have another group waiting for us to leave. It was my pleasure to meet your remarkable team. I have a deep appreciation for your work. And as a former diplomat who worked in our mission in Rome, I know that VNIRO is a reputable institution with a great potential for development. I hope that when COVID restrictions are lifted, we will resume visits to regions. So we hope to be your guests and to bring to you some positive agenda. I believe we have a lot to say and to do together. We have a stand at the expo. If you go through the central pass point, we are near the left wall. Please visit us. It will be our pleasure to discuss common topics of interest and for perhaps plans for the future. This publication is limited, unfortunately. So please evaluate the number of people who need an issue. Thank you for your cooperation. I wish you scientific success and be in good health. Thanks to all of our participants for Rome and to our interpreter. Thank you to all who participated in preparing this remarkable publication. I would like to recall that soon it will be published both in Russian and in English.